Hi, my name is Megan Ruth.
Hi, my name is Holly Stancy.
Hi, my name is George Lochran.
Hello, my name is Danielle Dutton.
Hi, I'm Justin.
Hi, my name is Stephanie Stoll.
My name is Colgan Ann.
Hey y'all, my name is Noah Kelder.
Hi, my name is Marley Skolton.
Hi, my name is Ellie Smith.
Hi, my name is Trisha Sullivan.
Hi, my name is Colin.
Hi, my name is Tyler Rutledge.
Hi, my name is Lauren Ozier.
Hi, my name is Ida Ajulubi. I also go by AJ.
Hi, my name is Jessica.
Hello, my name is David Alexander.
My name is Miguel Garcia Hernandez.
Hey, it's Carson Palmer.
Hi, my name is Ruth.
Hello, my name is Taylor Young.
Hi, my name is Madison Corfidge, and we are BME 435.
This video is a collection of students' reflection on taking BME 435, Computer Modeling of Complex Systems, a course I taught to a class of BME Junior in the fall of 2021. When I started teaching this course to this class of junior, I wasn't sure how far we would end up. I constantly asked myself, am I being too optimistic? Am I asking too much of them? Am I wasting time to try to do something impossible? In the end, I was amazed by the outcomes. I believe the students were amazed by them too. They probably never thought they could tackle complex medical problems in such a computer-assisted, hands-on, yet highly technical way after learning in short semester. In addition to teaching them the technical skill, I also venture out to encourage them to develop a integrative learning mindset, understanding the needs for learning how, in addition to learning that, and see themselves as a fighter who can overcome difficulties to prevail. Now let's hear from the student.
I individually got to work on a earwax cleaning device that consisted of laminar flow and diffusion. I also got to work with a team of members to determine the relationship between pressure and the cross-sectional area of the carotid artery. I enjoyed this class a lot, and I hope to continue to use the ComSol software after this semester.
Engineering has really taught me a lot, especially in this past year. Specifically in the class BME 435, I've learned to look at engineering problems from an entirely different perspective with a more creative and personal point of view. It has also taught me to look at everyday problems in general from a more technical point of view. I've started approaching problems looking more at the root and considering all of the factors involved in making something happen. I've realized that there can be a solution to any problem. Some may just take a little more work than others. I think the most important thing that I realized overall is that success isn't about who's the smartest. It's about who's the strongest and who's able to persevere. In general, I think engineering has made me a stronger person. It's made me appreciate all of the little details in life to a much fuller extent.
BME 435, Computer Modeling of Complex Systems, has been a rewarding journey into engineers' minds. I learned that you cannot be reliant on your previous knowledge to answer your problems for you. Instead, you must be the one researching the engineering and science underlying the problem by putting in the hard work. Only then can you give a proper answer. To do that, you must have a stable learning foundation, which biomedical engineering provides here at the University of Kentucky. We did a group project on the loading and deflection of an interspinous spacer used to treat lumbar spinal stenosis. Even though I had a passing familiarity with the spine at first, my group and I were able to create a computer model in COMSOL multiphysics. We learned about spinal physiology, the solid mechanics to represent loading in the body, and the different material properties involved. Finally, we learned about how this was medically relevant to our community, the patient receiving this life-transforming device that gives them an opportunity to move the very same day. I'm grateful to have had this insightful learning experience with Dr. Zhang.
I learned a lot from BME 435. I think one of the biggest things was it just opened up a whole new avenue of experimentation for me. I hadn't ever really thought about experimenting on a computer before running experiments in vitro, in vivo, or in patients before. But it's really a useful tool for experimentation to see if your concept will even work before you go through all that time and money of doing more complex tests. I think it was also really cool to learn about how computers actually solve problems, because a lot of what we do as engineers now is use computers to solve our complex math problems, but it's good for us to understand how that's happening. And this class really let me see that. I was really proud of some of the work that I was able to do through this class. This is an example of one of the things that I modeled. It's an electrosurgery device, and we modeled it at a bunch of different voltages and saw how that affected temperature and all sorts of cool things that actually had real applications to what we'll be doing in our jobs in the future.
BME 435 is a pretty tough class, but you can take a lot out of it if you're willing to work pretty hard. Doing the projects, it's probably a couple of the most rewarding things you could do in the class. The first one you do is individual project, which for me, I focused on the deformation and acceleration under load of a intervertebral lumbar disc, and how that simulation of a disc under load for extended amount of times varies. But also our group project was equally as intriguing. In my group project, we focused on the growth of an aneurysm via the blood pressure and blood viscosity as it moves through the artery walls itself. And you can see over here, we was able to model it and show the expansion of the aneurysm as blood is flowing through the artery. And then we were able to add a stent in and see how that pressure was able to be redirected through the stent and stop the artery from expanding, or the aneurysm from expanding at all. It was overall a pretty rewarding process.
Overall, I thought the course was really great and I thought it was laid out really well. The only thing I would switch would maybe be doing the math portion first over the COMSOL. I say this because it's really interesting to finally see our courses like Calculus 3 and Calculus 4 finally being used within our major in this math program, and then it's interesting to see that math then get applied to the COMSOL program, where you're working with different multi-physics and designing things such as like a blood vessel, a glucose sensor, and for example our team assignment was the external fixation device. Overall though, I thought this course was really valuable and something that would be really awesome to talk about with a future employer.
BME 435 has been a great learning experience for me because it's taught me how to take a real world problem that I can't solve by myself and be able to break it down into steps and recreate it through COMSOL. And this is very important, especially in our field in medical devices, being able to look at seen and unseen problems that are occurring and being able to take these and create a device or figure out what you need to do to fix this problem. And I'm very thankful for Dr. Z for teaching us these skills. And I know they're definitely going to come in handy one day down the road. And I look forward to taking this knowledge and putting it to good use.
I won't lie to you. This class is probably going to be one of the harder ones you end up taking here at UK. But one thing that Dr. Zhang told us early on in this semester that I agree with is that what you get out of this course is directly proportional to the amount of work that you put into it. If you really spend time in COMSOL, either doing tutorials or just messing around trying to figure things out, then that effort will end up showing on your final grade. And the earlier you start working on it, the easier it'll be on you in the long run. This class also provides a really good opportunity to get something tangible to put on your resume with the individual and the group projects that you have closer to the end of the year. So even if you might not have access to COMSOL once you leave UK, what job recruiters really want to see is that you're capable of working in a team to find a creative solution to one of these large-scale problems. So if I could just give you one piece of advice, it would be don't get discouraged if COMSOL seems absolutely impossible at first. It really just takes some time to get familiar with it.
BME 435 was definitely a learning curve in my education. I developed more complex ways of learning and strengthened my work ethic. Throughout this course, I developed models of a prosthetic finger and 2 different electrosurgical devices in a modeling software called COMSOL. I also got to go more in depth and learn the math behind the modeling program. My individual project, the prosthetic finger, took electric current and heat transfer into account to show joule heating. My group project incorporated the same physics modules as well to develop 2 different electrosurgical devices, a straight geometric electrode and a helical geometric electrode. These devices are used in the medical field for both cutting and coagulation during surgical procedures. It was neat to actually link this class to real-world devices. This course made me more interested in my studies and has added useful skills to benefit my near future. Though I may not use COMSOL again, I took away many learning points from utilizing it. If I were to go back in time, I would still take this course, and I recommend it for all upcoming BME students.
The biggest takeaway from BME 435 for me was the idea of transdisciplinary learning, or understanding and learning multiple engineering topics at once instead of kind of a separated understanding. So this was really important to me because it helped me connect more dots, and this was really made possible through in silico experimentation software that we used called COMSOL, where we were given a problem, had to design it, and really understand how each physics was applied to it to get our results. And we started off simpler and worked our way up to group projects where for my group we did electrosurgery. So we went from designing a probe to understanding how it would interact in the tissue, and then to even the manufacturing process of, okay, how much of the electrode do you even need to get the wanted results? So this was really important in my learning career, and I'm really glad I got to take this class, and I hope you're all excited to get to experience it as well.
I took BME 435 with Dr. Zhang. In this class, we learned about COMSOL and the math that goes along with it, and we got to model different scenarios. We would model an object, and then we would get to apply different kinds of physics to it and see how that model would actually be affected in real life, which was pretty cool to learn about because I never taken a class like this before or done any kind of modeling like this before. So I think it was beneficial for me to learn about COMSOL. And then one of the things that we did in this class that I really enjoyed was we did a group project. And in my group project, we had to simulate electrosurgery probes. And this is one of the probes that we built. It's a straight electrode. And I really enjoyed doing this project because I got to work with a team. And I think I learned a lot about COMSOL in this project, because if I was trying to work on the COMSOL aspect of it, of the project, and I didn't know what to do, there was always someone that I could ask that could help me figure out what I was supposed to be doing. And so that way I learned a lot more because I had so many resources of people that knew, that were strong in different aspects of COMSOL and could help me out. But I just wanted to thank Dr. Zhang for teaching this class. I think he did a really good job as a professor, and I hope to have him again in the future.
Dr. Zhang's BME 435 was definitely a very valuable experience for me. He taught us everything from advanced calculus principles to the ins and outs of the COMSOL multiphysics software. And COMSOL multiphysics is a very valuable tool to have in your engineering arsenal because it makes it easier to find a job very soon down the road, and it helps us be able to solve more advanced engineering problems that we otherwise wouldn't be able to.
This past semester in BME 435, we have been learning how to use COMSOL and the math behind how it works. COMSOL allows you to model real biomedical scenarios and gain insight into the effects and solutions of them. I have really enjoyed working with COMSOL, especially in the end of semester projects. The image behind me is the result of my group's project, where we modeled an external fixation device for a fractured femur. Through COMSOL, we were able to see how a normal walking load would displace the femur and the stresses that would occur within the bone and fixation device to determine its effectiveness. I hope to continue learning and improving in COMSOL so that I can apply it to future projects. It is a valuable skill to be able to virtually model the situations, as it can save significant time and money. Dr. Zhang also taught us a lot about how COMSOL does its simulations and the math behind it, which really helped me to understand what was going on and improve my knowledge of how to use the program. After this class, I look forward to continue improving my skills and using COMSOL more in the future.
I just finished up with the COMSOL class and I really enjoyed how realistic it was. And after the first 2 years of engineering, just getting to see those realistic applications of everything that we were learning, it was really awesome. And it was really great opportunity to get exposed to the other disciplines. I mean, chemical, mechanical, electrical, all of that. It was really awesome. And seeing how all of that is in the body and all of that is necessary to be integrated and considered at the same time. My group and I worked on closing a fracture in the femur using a external fixation device, essentially what it's called. And something that I really enjoyed working on was this load that's going to pop up. Initially, we had it just pointing vertically down, but upon more research, the femur is not actually a straight vertical line down, and neither is the load. So I got to decompose those into the respective axes and make them most realistic and beneficial for a physician and surgeon.
BME 435, Computer Modeling of Complex Systems, is a very interesting course. By the time you get to this course, you should have a pretty good understanding of, how a system of physics works on a body. This course allows you to simulate that in a program called COMSOL, which allows you to simulate different types of physics, let that be solid mechanics, electrical, thermo, anything really, on a solid body. I realized how important this class was when we got our individual assignment, which allowed us to create a model of any sort of biomedical engineering. Basically, I got to work with a product called deep brain stimulation, which is an electrode that goes into the subthalamus of the brain, and it sends stimulus electrodes throughout the brain to help disorders like tremors and Parkinson's. This program is something I'll be using way past school. This is a program that will help me develop skills, prototyping, and just getting an overall understanding of how a model would work. This class was definitely interesting. It's hard work. You're not going to get an easy A. You definitely have to study. You're going to have to be able to understand, the math behind it as well. And Dr. Zhang does a phenomenal job at really teaching this class. And I'm very happy that I got to experience it with not only Dr. Zhang, but with the classmates that I have. I know you guys will love this class, and I look forward for you guys to taking the class.
I really appreciated this class. And when reflecting back on it, I really think it deepened my understanding of all of my other physics classes. I couldn't understand how to explain to people what I was learning in my engineering classes until after this class happened. I appreciate how it was in our junior level of undergraduate learning, because that means I can struggle to understand it now and then just build on that knowledge going into my senior year and going into my career. I think this class is very beneficial for my career because I can model theoretically different problems and their solutions that you can't show in real life. And on a computer, it's a lot easier to show the details and to color code how pressure and stress are impacted in an aneurysm than it is to just explain it in person. I really appreciated this class.
In BME 435, Computer Modeling of Complex Systems, I was able to learn how to take a real-life, real-situation problem and import it into a software to be able to study each aspect of that problem. COMSOL allows you to take a real-life physics problem and apply various parameters, material settings, and different types of physics to accurately model it and understand the results and change these parameters to find the most ideal outcome. Not only did I learn that, but I also learned the math behind COMSOL and how it solves each partial differential equation to obtain the results of the modeled physics. Overall, this course taught me a lot about understanding real-life models and the math behind this program, and it's a great program to be able to use later on in life. And I think that it should be a course that every student should take, not only in the curriculum of BME, but I think all engineers as well.
Once I figured out that we had to do these videos, I knew exactly what I wanted to talk about. Through our coursework, we're exposed to several different aspects of the manufacture and design processes which go into every single biomedical device that you see on the market. Through these interactions, we learn to not only design, but to model and simulate the devices in order for us to truly see every single step of the design process. With that idea in mind, I would like to show you 2 different projects that I've been working on recently as part of my coursework. First, you can see a model for our Fitbit, which we did as a part of our SolidWorks class. This project allowed us to break down the parts individually and design everything from the glucose sensor to the touchscreen to the band that goes around the body. Here you can see the parts being broken down individually based on color. And now I want to show you a part of our 435 class which revolves around COMSOL modeling. Here in this project, we decided to model and simulate an electrode to see the heat dispersion as it reaches the tissue. Not only do we get to work on fun projects like those, but the coursework also enables you to pursue your own dreams and pursue your own projects. For example, I'm using some of the ideas that we learned in school in order for me to design an own project and enter a scholarship. So it's not only about the coursework, it's not only about the class, it's not about the projects. It's about personal enrichment and this new mindset which biomedical engineering integrates into who you are.
My learning experience in this class was kind of interesting because it kind of rode the line between like me not knowing anything at all and then me like getting stuff on the first try. So it was definitely like an interesting kind of learning experience, kind of not really like anything I've ever had before. And it kind of forced me to like actually learn Calc 4, which Calc 4 did not teach me very well, so that was kind of nice, but also horrible at the same time. Thanks for everything, Dr. Zhang.
One of the things that I really wish we would have done is to actually break down all the tutorials that we had to do into little modules. If we had had like 1 to 3 tutorials in a single module, and then at the end of that week we're tested on those on one or all of those 3 tutorials, I feel like it would have been a lot better for me, because for most of the exams we were just going right in with no idea on what was going to come out or what was going to be set. And with all 16 tutorials, it wasn't very helpful to show that you had read if maybe the parts that you were able to cover weren't the parts that came on the exam. But one thing I did really like about the class is that when we got into the math section, we were actually able to know what part we were supposed to study. And for me, that was really helpful to go over all those calculus materials again, and also not have to study everything, like actually know what particular sections I should be focusing on, I should be practicing, because it gave me more time to really sink into those particular chapters that we were being tested on by that time, and or for that week. And by the time the final came around, I was able to basically understand all the math that we covered. So yeah, those are my 2 takeaways from this class.
I'm so thankful that I was given the opportunity to take the Computer Modeling of Complex Systems course. It has allowed me the opportunity to honestly establish a new way of learning. Dr. Zhang was constantly going on about the importance of integrative learning and how we can use it to apply it and solve real-world problems. Although this course was challenging at times, it definitely gave me the opportunity to fully develop myself and has been honestly the most rewarding course I've taken so far here at UK.
As many of my classmates have already stated, the BME 435 class was pretty interesting. I think I started out pretty strong on the material, but when it got to the heavier material with more and more physics being implemented, I think I got a little bit lost, if we're being honest. Working as a team is something that we have to experience throughout our entire UK career. From the beginning of EGR 101, 102, and all the way until now with BME 435, working as a team is a big portion of your career as an engineer, and I feel like that's very important to learn early on and to drive that home with this semester. We all have our own different strengths, and it's important to recognize those strengths and put them to good use.